Hello everyone, we are back with another very important concept, bearing. Bearing is basically an angle between two objects and it is used to navigate the path or to find out location of an object. Now, while doing bearings, you need to be aware of only two things, that always start from north and always move clockwise. That's it. These are the only two things you have to be aware of. Now, why do we always start from north? So in earlier time, when there was no compass or no tools to indicate the directions, people used to take reference of north star to find out north. So it's easier to locate north than any other direction. So in today's time also, we take north as the reference to find any other direction. Now, if you get confused where is east and west, you can always use this: never eat soggy vegetables. Okay, that will help you to find out east and west. You are going clockwise from north and never eat soggy vegetables. Now, how does bearing help in navigation? Suppose there is a statement which says that a flight flies for 500 kilometer on a bearing of 85 degrees, or a flight got instructions to fly on 85 degrees for 500 kilometers, right? So how will the flight move? Where is the flight right now? So suppose this is your flight, it is on point A, that's the starting point, and from here it has to move for 500 kilometers on a bearing of 85 degrees. Now, as we always take reference from north, so we have drawn a north-south line on the point. North-south line is just a simple straight vertical line. So that's the north-south line. Okay. Now I always have to move clockwise. So let's see, where will my flight be? So that's the protractor. Now, as I have to move clockwise, so which scale is going clockwise? The upper scale. So I am going to see the upper scale. Now on the upper scale, I have to move on 85 degrees, which is here. So my flight has to be somewhere here on the distance of 500 kilometers. So if I draw a line there, so that angle, this angle would be 85 degrees, and as we always write bearing in 3 digits. Why do we write in 3 digits? As the complete angle is 360 degrees, which is a 3 figure. So we also write bearing in 3 digits. So if the bearing is 85 degrees, we write it as 085. Okay, so that's the bearing of this point B, where your flight is now, from the starting point A. Okay, now if the question asks you to find out bearing of A from B, now be careful about these statements. This is a bearing of B from A. Bearing of B from A is 85 degrees. Now, if you want to find out bearing of A from B. Now look at the statement from B. So if you are measuring the bearing from B, then you must be standing at B, right? Because if you are measuring angles from this point, then you are standing at this point right now. So wherever you have to measure your angle from, you draw a north-south line there. It's that simple, right? So we have to measure the angle from B. So we are again going to draw a north-south line on B, which is again a vertical straight line. So that's my north-south line. Now start from north and go clockwise. So that's my north. I'm going to start from this point and I want to move clockwise. So basically I want to find this angle, right? That's my starting point, and the line connecting the starting and the end point is this. So I want to find angle here. Okay, now we all know the basic lines and angle rules. A straight line draws an angle of 180 degrees. So the angle up till here is 180 degrees. And what can we say about this angle here? If you have studied angles between parallel lines, if there are two parallel lines and a transversal crosses them out, these angles which are forming a Z are equal to each other. These are known as alternate interior angles. Alternate interior angles are always equal. Now both the north-south lines are also parallel. So if this angle is 85 degrees, this angle here is also 85 degrees, right? This complete angle is going to be 180 plus 85 degrees. So bearing from B to A, bearing of A from B is going to be 265 degrees. So bearing of A from B is 265 degrees. These are the basics about bearings. You just have to be careful about two things. Start from north and go clockwise. Never move anti-clockwise, never start from any other direction. You always have to start from north and you just have to move clockwise. That's it. Now let's solve some questions based on bearing. I have categorized these questions. These are very basic ones. Then we have basic questions and then we'll move to extended questions. Now for the first question says, find the bearing of B from A. It means you have to start from A. And what is the rule for bearing? We always start from north and we always move clockwise, right? So we have to start from A and we have to look at the north. That is why I have drawn a north-south line on point A. So that's my north. I have to move clockwise. So I am starting from north and I have to move clockwise, and that's the line where A joins B. I want this angle which is already given to me. So the bearing of B from A is this angle which is given. So the answer here would be 105 degrees. Then second question says, bearing of A from B. Now bearing of A from B. So you have to start from B. So on B I have drawn a north-south line and I have to move again clockwise. So let's move clockwise from B to point A. I need this angle which is again given. So bearing of A from B would be 260 degrees. The third question says, find bearing of B from A. Bearing of B from A. So we have to start from A. So I'll draw a north-south line on point A. That's my north. And what's the rule? Move clockwise. So I am going to start from north and I have to move clockwise. That's my line. So I need this angle here. Now what information has been given? This angle has been given. This is also a vertical north-south line. So if this complete angle till here is 260, and as we know it's a straight line, so angle up till here should be 180, right? So this angle here, this small part, must be 260 minus 180, which will give you 80 degrees. And if this angle is 80 degree, we can say that this angle would also be 80 because they are alternate interior angles. So this is also 80 degrees. Let's move to the next question, which is, I hope you're able to see, a boat sails for 14 kilometers on a bearing of 60 degrees. So we have 14 kilometers on a bearing of 60 degrees. Then sails for another 9 kilometers on a bearing of 200 degrees. Make a scale drawing. Now what is a scale drawing? A scale drawing is a representation of a real situation, and using a scale drawing you can measure the distances and you can find out what is the actual distance between an object. And the scale given here is 1 centimeter is equals to 1 kilometer. Means 1 centimeter of the map or of the drawing will be representing 1 kilometer of real life. Okay. After drawing the scale drawing, we have to find out the distance between the starting point and the end point. Now first we need to make a scale drawing using the scale of 1 centimeter is to 1 kilometer. So let us say the starting point is A. So we are here on point A. Now we have to move on a bearing of 60 degree. We are here on A. We have to start on A. So I'll be drawing again a north-south line on point A. And on what angle do I have to move? I have to move on 60 degrees. So let's see. That's my protractor. And I have to move clockwise. So I'll be seeing the upper scale because that is going clockwise. Here is my 60 degrees. Now I have to move for 14 kilometers. Now I cannot represent 14 kilometers on a piece of paper. I'll be using the scale. For 1 kilometer I represent it with 1 centimeter. So 14 kilometer would be represented by 14 centimeters. So we'll draw a line of 14 centimeter on a bearing of 60 degrees. So that's where my ship is after the movement of 14 kilometers. Let's say that's position B. Okay, and this is 14 centimeter. Then the ship sails for another 9 kilometers on the bearing of 200 degrees. Now we are here. We have to move from this point. So again I'm going to draw a north-south line on B. And I have to move with 200 degrees. So this is my north. I have to go clockwise and I have to move an angle of 200. Till here the angle is 180. So after 180 you need 20 degrees more. So let's see. Again I have to move clockwise. So I'll be seeing the scale which is going clockwise, which is the upper scale again. That's another 20 degree over 180. So that's the second point. That's the angle of my second point, 200, and we have to move for 9 kilometers. That would be represented by 9 centimeters. So here is my finishing point, point C, and that's 9 centimeter. Now our scale drawing is complete. Now what do we have to find out? We have to find out the distance between starting and end point. That's my starting point, that's my end point. I want to find this distance. So let's measure. As it is a scale drawing, you can always measure from it. And that this distance is 9 centimeters. The distance is 9 centimeter, and as we are using a scale of 1 centimeter is to 1 kilometer, so my 9 centimeter must be representing 9 kilometers. So that's the distance from my starting and end point. Next question. A boat sails for 14 kilometers towards east and then 9 kilometers towards south. Find out the bearing of finishing point from the starting point. Now this question belongs to extended, and you would need to use trigonometry to solve it. Let's see. A boat sails for 14 kilometers towards east. Now let's say we are here, the boat is here, point A, and it is sailing for 14 kilometers towards east. So that's our 14 kilometers towards east. Okay, now your boat is here, and then 9 kilometers towards south, and it goes towards south for 9 kilometers. Now your boat is here, that was point B, this is point C. Now we have to find out the bearing of finishing point from the starting point. So we have to start from the starting point A. So as we know the rules of bearing, we have to start, we have to draw a north-south line on the starting point. So I have drawn a north-south line here, and I need to find out the bearing of the finishing point, which is this point. So let us join these two points by a line, and I need to calculate this angle. How do I need to calculate this? Because we always move from north and we go clockwise. So I need this complete angle. Okay, now we have multiple information given in this question, and some basic information we already know, that two perpendicular lines make an angle of 90 degrees. Here also these lines are perpendicular, so this angle is of 90 degree. And to find out this complete angle, we need this portion of the angle as well. This portion we are already having, which is 90 degree. We need this portion. Now how to calculate this portion? There are no other angles given. If the other angle was given, we could have used the angle sum property of triangle, but it is not given here. So in these type of questions, we can use trigonometric ratios. We have three basic trigonometric ratios: sine, cos and tan. Sine gives us relation between the hypotenuse and the perpendicular of a right angle triangle. Cos gives us relation between hypotenuse and the base, and tan give us the relation between the perpendicular and the base. Now how do we identify which one is the perpendicular, which one is the base? Look at the angle we need. This is the angle we need. 9 kilometer is opposite to this angle, that is why that would be our perpendicular, and this angle is made up on the 14 kilometer line AB, so that would be the base. Okay, now tan give us the relation between base and perpendicular. So using base and perpendicular we can find out this angle. So we can use tan theta. Theta represents the angle. Tan theta is equals to perpendicular over base. Perpendicular is 9 and my base is 14. Now this is the value of tan of this angle. I need only this angle, so I'll be sending tan there, or I'll be inversing it. So my theta or my angle would be tan inverse 9 by 14. Now if you'll require a scientific calculator, I need to find tan inverse. If you can see, it is written in yellow over here. So all the yellow functions work with shift. So I'll press shift, this button, which would give me 10, and I need tan inverse of 9 by 14. So 9 by 14, and that will give me 32.735. Angles should be rounded to 1 decimal place. So my angle here would be 32.7. So this theta is equals to 32.7. This angle is 32.7, and I need this entire angle. So this part was 90 and the remaining part is 32.7. So the bearing of finishing point from the starting point would be 90 plus 32.7, which is 122.7 degrees.